All right, new chapter, chapter 5.1. Now, I don't have the videos. I will, hopefully by the end of today, I'll have the videos on, what do you call that? Digital lockers on Teacheries. So, for some reason, I took chapter 5 down. I don't know why I did that. Maybe because I finished chapter 5 in the other class, but I should have kept them up there for you guys. But they'll be up there pretty soon. I don't have the worksheet right now because the machine's down, but I do have the office working on it. So, by the end of class, I'll send somebody down and get the worksheets. All right, here we go. You ready? We're going to talk about triangles in this chapter. This whole chapter is all about triangles. Now, I got to warn you, you really need to stay up on this stuff, especially the next two lessons. Okay, this lesson and the next lesson. You really, really have to pay attention and concentrate. There's two major things we're going to talk about in today, and then two major things we're going to talk about tomorrow. So take good notes on this. Go home tonight, watch the YouTube video. All right, sometimes hearing the same thing 2 or 3 times makes a difference. All right, I've had people say, well, what's the difference? I already heard it in class. But you really didn't. You really didn't. As much as you think that you pay 100% attention, you really don't. There's still things, even though you're trying to pay attention, there's still things that you miss. All right? So make sure that you watch these videos. Take good notes on them. Take good notes when you're watching the YouTube videos at home. That's my suggestion to you. It will really be helpful. All right, let's talk about this word right here first of all. Okay, it's called a, oops, started off with the wrong one. Perpendicular bisector. Write that down. Perpendicular. And you know what all these words mean. It's just we're putting these two things together. Perpendicular bisector. All right, so what we're going to do is let's have a, just have a line right here. And we'll have an endpoint right there at A and an endpoint right there at B. And let's say, do this in another color, let's say I want to draw another line or another line segment that's the perpendicular bisector of the segment. Well, that does two things, doesn't it? First of all, you got this word perpendicular. So I need to draw another line that's perpendicular to this line. All right, so what does it mean to be perpendicular to this line? We've talked about that a bunch. Makes a right angle, right? We have talked about that in here, right? Perpendicular? Yeah, okay, just making sure. You guys are giving me this look like, what are you talking about? All right, so perpendicular. So does that mean it goes right there? Okay, that looks perpendicular, doesn't it? Okay, or does it mean it goes here like this? Okay, well, that's perpendicular, right? As long as it's a right angle. Okay, as long as you have a right angle there, it's perpendicular. But there's a second part of this. It's perpendicular and it's also a what? A bisector. What does it mean to bisect? Cuts it into two equal parts. Exactly right. Okay. So what am I going to have to find then with this AB? I have to find the midpoint, aren't I? Okay. Now if I click on this particular program shows you actually where the midpoint is, right there. All right. So I'm going to put a little dot right there. All right. And so that's the midpoint. So this line, this blue line right here, do you see that? Now I can make it as long as I want. It doesn't have to be that. It could be like this. Okay, it could go through this. It doesn't have to stop right on it like this. All right, it could go through it. But what does it have to do? It's got to be two things. It's got to be perpendicular, and it has to do what to this segment? It's got to bisect it. So where's it going to go through? That midpoint, right? It's got to go through right there, and it also has to be what? A 90-degree angle, a right angle. Exactly right. Everybody see that? So this blue line right there is the perpendicular bisector. And it bisects line segment AB. All right, so it splits it into two equal parts. So let's call this C right here. So what do I know about AC and BC? What do I know about those two segments? They got to equal each other. So what could I put there? Just to show that they're equal to each other. Little tick mark. Little tick mark here. Oh, let's make it go through. Tick mark here, little tick mark there. What does that mean? That means that what? That AC is equal to what? CB. I'll call it BC. Is that right? So AC and BC are equal to each other if this is the perpendicular bisector. Everybody got that? All right, so you have to know what the definition of perpendicular bisector is first. Now we're going to do some things with a triangle, right? We said earlier we're going to deal with triangles. This whole entire chapter is dealing with triangles. Right now I don't see a triangle, do you? But we're going to use that perpendicular bisector thing with a triangle. Now watch this. I'm going to draw this triangle. I'll make this quite a bit bigger because we're going to draw some stuff inside of that triangle. Make it super big. Okay? Now what I'm going to do is I'm going to take this triangle and I'm going to draw 3 perpendicular bisectors. Let's do that. So I'm going to draw 3. I'm going to do the symbol. That's the symbol for perpendicular, and then I'll just write the word bisector out. Okay, I'm going to draw 3 perpendicular bisectors. Everybody see that? So what does that mean? We're going to take one of these sides. We're going to do it 3 times, but I got to take one of these sides, and I got to find. Let's take this side. Actually, let's ungroup this. I'll go like this. Let's take this side right here, and I want to draw the perpendicular bisector to this side. So that means I have to do 2 things. I have to draw a line that's perpendicular, and I have to do what to that segment? Split it in half, right? Everybody see that? So let's do this. Let's first of all take this side and find the midpoint. Where is the midpoint? Right where those 2 dots are, right? Okay, so right there. I'm going to draw a little dot. Everybody see that? Actually, I wanted that dot yellow. Let's make that yellow and make it a little bit thicker. There we go. All right, so that's the midpoint of this side right here. Now, I want to make a line that's perpendicular to this side, and it goes through the midpoint. So what do? Just put my line right here and just make it go through. You could go all the way through. It doesn't matter. It doesn't have to stop here or anything like that. But look what I just did. And if I put a right angle right there, what did I just do? I drew the what? Talk to me. The perpendicular bisector of this side right here. And let's call this ABC, this triangle. So I found the midpoint of BC, and I drew a line that's perpendicular to it. Everybody see that? Okay, good. Now, what do you think I'm going to do? I'm going to draw 3 of these. So where else do you think I'm going to go? I found the midpoint of BC. What else do I have?
AB.
Let's do AB. All right, doesn't matter. You can go AB or AC. It doesn't make any difference. So what am I going to do now? I'm going to find the what? Find the midpoint. Now, this one's slanted a little bit, isn't it? So I'm going to have to figure out. So here's my 2 dots right here. So if I go over, does that look about right? Yeah. Let's put a dot right there. And yeah, every time I click on that, it makes it white again. Let's make it. I'll tell you what. Let's make it all yellow. Is that all right? And now what am I going to have to do? I'm going to have to draw a line that is. I'll tell you what. I'll cheat a little bit. I'm going to copy and paste. I'm going to copy and paste this. I'll make it yellow, make it 2 point, and I'm going to make this so it's 90 degrees. Since I got this program, I can do this, I think. Rotate, and let's rotate it 90 degrees. Yeah, there we go. That's perfect 90 degrees right there. That's kind of cheating, isn't it? But that's okay. Works nice. Now what I'm going to do, this is a right angle, because I made it 90 degrees to AB, didn't I? So it's a right angle, and where does it go through? It goes through the midpoint. So guess what that line is? It's a what? Perpendicular bisector. So far I've got 2 perpendicular bisectors. Both of those yellow lines are perpendicular bisectors. Are you getting the idea? All right, so what do you think you're going to do now? Take AC and find the midpoint of AC. So if I scooch this about right there, does that look like right in there? Yeah. Right there. Make it yellow. Make it 2 point. Okay. Did I do that? Oops, I didn't know. Let's try this one more time. Okay, there's the midpoint. Let's make it yellow again. Try it again. Make that 2 point. There we go. Now we got it. Now what am I going to do? I need a line that goes a right angle to this point, don't I? So, now you could just kind of eyeball it yourself if you wanted to, but I'm going to do this. I'm going to copy and paste, and I'm going to rotate it 90 degrees right there. I'm going to make it yellow and make it 2 point. All right. Now watch what I'm going to do with this yellow line. I'm going to take this and put it where? Right there. Everybody see that? Now I'm off just a tad, but oh, there we go. That's pretty close. Because I think I was off on that midpoint anyway. There we go. Now look what happens to these. Now this is right there. Everybody see that? Yeah, look what they do. Look what all 3 of those lines do. They intersect, don't they? And you may not think that's a big deal. I think it's a pretty big deal. If I take the perpendicular bisector of all 3 of my sides, they actually intersect each other at 1 point. Make that a little bit like that. Okay, everybody see that? That point is really, really important. Let's put some other letters in here. Let's call this D, E, F. Let's call this G. All right. See that point right there? That point is really, really important. I'm going to do this in another color now. By the way, when you have more than two lines intersect at one point, we say that word is concurrent. Write that down. Okay, 3 or more intersecting lines. Intersecting lines. Okay, so if you have 3 more intersecting lines, and they intersect at the same point, I should say, okay, they intersect at the same point. Okay, they're not just 3 lines that intersect. It's not like that. Those are 3 lines that intersect, but they don't all intersect at the same point, do they? So that's not concurrent. Okay, 3 lines that intersect at the same point, we call that concurrent. So we have concurrent lines right here. With me so far? This point right here, see that point G? That's called, what do you think? The point of, well, it's more than that. It's, remember, this word is concurrent, so we're going to say concurrency. Concurrency. All right, not a huge deal, but it is nice to know some vocab on this. All right, so the 3 lines are concurrent lines because they intersect in one point. That actual point right there, point G, is called the point of concurrency. Now, there's something really special about this. When you do 3 angle or perpendicular bisectors, that point of concurrency has a name, and they call that the circumcenter. So that point G right there, so point G, I'll write this, point G is the circumcenter. And this is really what I want you to know. Circumcenter. All right, so point G is called the circumcenter. Everybody writing this down? Cookie, you getting all this? Okay, write it down, please. Daniel, let's write this down. So point G is the circumcenter. That's really, really important. Now, there's something special about the circumcenter. It's not just that these 3 lines intersect at that point. That's kind of cool already, but it's not really what I care about. Watch this. Let's go to a different color. And I want to show you something about this circumcenter. See this point right here, this point of concurrency? That's a very special point. Let me show you. If I took this distance and I figured out how far it is to that vertex right there, then I took that point G, that circumcenter, and I went to point C. Where else do you think I'm going to go? From G to where? To A, right. So if I'm going to go from G, I'm going to go to A. What do you think might be true about those 3 purple lines right there? They're exactly the same. They do intersect, but that's not really what I care about. Look at the length of all 3 of those lines. Look at AG and BG and CG. They're all exactly the same. Yeah, that's weird, isn't it? I think it's kind of cool. Thank you very much. I think it's pretty cool that they're all exactly the same. So look what we did. How did we find that circumcenter? We drew the perpendicular bisectors, didn't we? All right, so we found that circumcenter. Now, what's true about that circumcenter? Yeah, it's the intersection of all the perpendicular bisectors, but what's even more special, what's special about that point? What's special about that point is that it's the same distance from all 3 vertices. You see that? So all 3 of these lines, I could put a little tick mark here, 1 here, and 1 here. And all 3 of those distances are exactly the same. You can do that with any kind of a triangle. There's nothing special about this one triangle that I put up here. You can do that with any triangle, and that circumcenter is going to be the same distance. So, what do you think? What kind of question do you think they could ask you on a homework problem? They could say that AG is 5, and what's the length of CF? Or not F, CG. What's the length of CG? It would have to be 5, right? Does that make sense? No math involved, right? If that's what I told you, then that's what I asked. What else could you tell was BG, right? BG would be what? 5. Would be 5 as well. See that? Now, they're probably not going to make it quite that easy. Do you think? Yeah, they might do something like this. Now, I'm just making these numbers up because I don't know what works out real nice. But they'll say like AG is equal to 5x minus 2, right? And then CG is 3x plus 1 or something like that, right? You've seen this a bunch of times, right? The whole year we've been doing stuff like that. So what would you do with this 5x minus 2 and this 3x plus 1? You would set them equal to each other. That's right. Make sense? But before you set them equal to each other, you got to know that they're actually equal to each other, right? So if they tell you that this is the circumcenter, then you know that all three of those segments are equal to each other. What's equal? From the what? From the circumcenter to the vertices, right? Vertices is just plural for vertex, right? So if I go from here to this vertex, from the circumcenter to the other vertex, from the circumcenter to the last vertex, all three of those lengths are exactly the same. Now, it's not that hard. You look at it and you say, okay, I think I got that. But we're going to learn 4 different things. All right, this is the first one. This is the very first one. So you got to keep them straight. That's the hardest thing about this, is just keeping which one is what. All right, keeping it straight. This one is called the what? The circumcenter. Now, I really wish I had some cool way of remembering which one was the circumcenter and which one was the other things that I'm going to talk about. And I really don't. I've been trying to think of a easy way. You just have to remember it, okay? And I have a hard time sometimes remember it myself unless I'm not studied up on it. If I'm studied up on it, it's in my head. But if I'm away from it for a while, I have a tendency to forget. So the circumcenter, how did we find the circumcenter? We found the 3 what? Perpendicular bisectors, okay? And how did we find the perpendicular bisector? We found the midpoint, and then we made a perpendicular line to that midpoint, right? We extended it far enough where they're actually going to intersect. Everybody see that? Now, if you wanted to make this a little bit prettier, see how this line goes way out like this? If you just wanted that line to come to there, you could. Or if you wanted this, if you wanted this line, let's try that again, like to come to here. Or actually, if you wanted, you wouldn't want to do that. Okay, like to there, and then if you wanted this one, just to look a little bit nicer, so all these things aren't, sorry. Let's try that one more time. If I can grab it, there we go. See what I'm doing? I'm just trying to clean it up, just so it looks a little prettier, so you don't have all those things all over the place. So what are the yellow lines? The yellow lines are the perpendicular bisectors. Okay, the pink lines are the distance, right, from the circumcenter to the vertices. And what's true about the pink lines? They're all equal to each other. Are the yellow ones all equal to each other? No, not at all. Perpendicular bisectors aren't equal. Look how short that one is, and look how long that one is. There's no way that they're equal to each other. But the pink ones are. Somebody asked, is it always going to be true? Yeah, it always will be true. As long as you drew the perpendicular bisectors of all 3 sides, it's going to meet at one point called the circumcenter, and that distance is the same to all vertices. We got that? It's a lot of stuff. I'm throwing a lot of new vocab words at you. We got this word concurrency and concurrent lines and perpendicular bisectors, circumcenter, and all that. So it's really important that you go back and you skim through this video, all right, and you watch it so it stays fresh in your mind. I think it really, really is helpful. Okay, so that's one down. We're going to do, I said we're going to do how many today? Not today, just 2 today. We'll do 2 tomorrow and 2 today. So this is our first one, and it's called the circumcenter. All right. All right. Let's do another one. Let's keep the same triangle. Let me see if I can grab it. I don't know. Did I copy that or not? I don't know. Let's see. We'll see if I did or not. I thought I missed that. That's all right. I'll connect it. Right there. Okay. So we'll just use the same triangle. You don't have to use the same looking triangle. You could use different triangles, but just for the sake of doing these problems, we'll just use the same triangle. All right. Now what we're going to do is this. Now we're going to do. Let's keep the same color coordination here. All right. So we work this out. Now what we're going to do is we're going to draw 3 angle bisectors. Now that's a little different, isn't it? So what are we bisecting this time? Are we bisecting a line segment? No, what do you think we're bisecting? An angle, that's right. And there's three, right? Well, there's three angles in a triangle, so there must be what? Three angle bisectors. Now on this one, I'm going to have to guess a little bit. I can't use my program to find exactly bisecting this angle, so you'll have to help me out a little bit, all right? So what we're going to do, and we'll just name it ABC again. Which one do you want? A, this one, and then down here, B and C. All right. So what we're going to do now is we're not finding the perpendicular bisector. We're not bisecting the opposite sides, are we? We're bisecting the what? The angles. So what am I doing to this angle A? I'm trying to split it where? Into two equal parts, into half, right? I want to split it in half. So would it be like that? Nah, because that angle on the left is real skinny. That one on the right is bigger. Would it be like that? No, it would be somewhere right in there. And I'm going to take this to the other side, all right? So tell me when you think I've split that thing in half. About right in there? Okay. We're just eyeballing it, right? We're just looking at it and just trying to get a good guess. So that is an angle bisector, which means what's true about this little angle and this little angle right here? They're equal to each other. So if you want to, you could always do that, couldn't you? Just to show that they're equal to each other. So that's an angle bisector. Does that necessarily hit the midpoint of the opposite side? No. Okay, this looks like it's scooched over a little bit closer to the C than the B. So no, it has nothing to do with hitting the midpoint of the opposite side. We've only bisected this angle. Okay? All right, let's do that to two other angles. Let's go in order. Let's go to B. And so I'm going to start at B, and I want to bisect that angle. So is it going to be like that? No. Is it going to be like that? No. Where do you think? About right in there? Okay. That looks pretty close. So that means this little angle and this little angle are equal to each other. So what are we bisecting again? We're bisecting the angles. All right. Now we got to do it to the other angle, this one right here. Now, just take a wild guess. You saw what happened when we did the perpendicular bisectors. They were concurrent lines, weren't they? So what do you think might be true here? Yeah, they're going to be concurrent as well. So look, where do you think they're going to intersect? Right there, okay? So just to make sure that I do this right, does it look like these two angles are equal? Yeah, it does, doesn't it? All right. Now again, I don't have a way to show you that they are exactly equal, but if they were, they would all intersect at one point. Now, we don't call that's the point of concurrency, but we don't call it the circumcenter because we found it different ways, didn't we? All right, we found this by doing what? Finding the angle bisectors. So, but there is something special. What do we go? We went to that purple color, right? So watch this. Now, remember how in the circumcenter we went to the vertices and we said those are all equal? Do you think that's true here? No, because look, that and that and that. Does it look like all three of those are equal to each other? No, absolutely not. That looks way shorter than that one, doesn't it? Okay, even looks a little shorter than that one right there. So that's not true. So we're not going to do that. Oops. Uh-oh. Boom, boom. Yeah, there we go. That's what I wanted. Okay, so we got to figure out what's true here. Well, there is something that's true. Watch this. If I went from this... Oh, by the way, I got to tell you what the name of that thing is, don't I? That thing right there, it's called the incenter. Not the circumcenter, it's the incenter. Now, again, like I said, I wish I had a way that you could, nice little way that I could say, well, it's circumcenter because of this, and it's incenter because of this, and it was a nice little easy way to remember. I really don't. I really don't have a nice easy way to remember which one's which. Right, but this one's called the incenter. I'll tell you what, we'll label it after we're done here. Watch this. If I take this point right here, there is something that's equal. If I took it and took it to the perpendicular to this opposite side, that would be called the distance. Remember we did that on another test? We said find the distance between a point and a line. It was always perpendicular. Remember I took off points, or I took off, I didn't give you the problem correct if you didn't put the right angle symbol and all that. So watch this. So this is the distance from the incenter, right, to this line CB. What else do you think we're going to draw? Let's go to here. Now, again, I'm going to have to eyeball a little bit. Tell me when it looks perpendicular. About right in there somewhere? That looks pretty close, doesn't it? Okay. And so that's perpendicular. And then let's go over here, perpendicular. It looks pretty close to right there, doesn't it? Maybe we'll scooch it over just a little bit. maybe about right there. And we'll say that that's perpendicular right there. Now look at these three purple lines right here. What do you think's true about them? How would you say? They're all equal to each other. Exactly right. So here's what they say. That the distance from the incenter to all three sides of the triangle are the same. They're equal to each other. Remember what the distance was. The distance was what? It was from a point perpendicular to that line segment, right? So is this the distance from this point to this side? Yeah, because it's perpendicular. Is this the distance from this point to this side? Yep. Distance from this point to this side? Yep, because they're perpendicular. Okay? Caitlin, do you have a question? Okay. So look at this. So what's true about all three of these purple lines? They're all equal to each other. So if I wanted to, I could say D, E, and F, couldn't I? Actually, don't put the E there. E would go here, right there, and then right there. Okay, and we'll call this, I don't know, G again. So what's true? DG equals what? EG, which equals FG. Everybody got it? So those are the two things that we're learning today. The first one was what? What was that point?
Circumcenter.
It was circumcenter. How did we find the circumcenter? What did we draw? We drew three what? Perpendicular bisectors, okay? That was circumcenter, got it? And what was true about the circumcenter? It was equidistant from the vertices, that's right. Just as a little reminder, let's pop back up here. Look, the circumcenter was equidistant from the vertices. Everybody see that? Well, how'd you find the incenter? Big hints, it's all here. How'd you find the incenter? You drew what? Three angle bisectors. So we took the angles, we bisected them, and they all intersected at one point. What was true about that one point? Well, we call it the incenter, and it's got to be equidistant from the three sides, right? It's the same distance from the three sides of the triangle. And that's how they say it in the book. They say it's equidistant, right? The same distance from the three sides of the triangle. Why did I put it perpendicular? Because the definition of distance, right, is from a point perpendicular to that side. That's why I put a little right angle symbol there. Got it? And same thing holds true. I could say that, this was 3x plus 7, and then I could say that this was like 10, and they say solve for x. So what would you do? You'd set them equal to each other, and then you'd solve, wouldn't you? Make sense? Okay. So you kind of see what they're going to do with that right there. Alrighty. Just have a few minutes. I'll tell you what, let's do this. Yep, I got him. She brought him to me. Well, I think it might be better to do an example first. Let's see if we can do a quick example. Group that together and we'll make it 2 points. Okay. Okay. I just have to do this really quick. It says point P is the incenter. To say, how did you find the incenter? You bisected, right? I'm looking at page 326 at the bottom if you want to look at that. And then, right, we bisect this angle. Does that look kind of bisected? And we bisect this angle. That looks, I'm off somewhere. But anyway, that's close enough. Alright, so that's point P. It says it's the incenter. But what's true about the incenter? It's the same distance from all three sides, isn't it? So that's a right angle. That's right. Nah, this is not going to look too great because I was off a little bit. I didn't eyeball it very well, did I? But that's okay. Even if it doesn't look like it, we're still... Yeah, he's laughing at me. That's okay. So watch. That's 31 degrees right there. These blue are all perpendicular. They tell you that this little bit is 12. This is 27. This is 20. This side right there is 20. Okay, and they say, and P is the incenter. All right, P is the incenter. So what does that mean if it's the incenter? Well, a couple things. We know that that angle's bisected. So if this is 31, what's this one?
31.
That's 31 degrees. If this is 27 degrees, then this is 27 degrees. Oh, I see what they're doing. Okay. And what do they ask for? PK. PK. You don't have any letters here, but they want you to solve for, there's K right there. They want you to solve for that right there. How in the world can you solve for PK? Look, I don't know any sides, but I do know I have a right angle, don't I? Now, what's true about all the blue ones? Supposedly. They're all equal to each other, right? They're all equal to each other. But look at this triangle right here. What you have to do sometimes, do you see this right here? I'll redraw it. And then this right here, right there. Everybody see that? Okay. What is the length of this side? It's 20. What's the length of this side? It's 12. Now this is the distance, right? This side right here is the same as PK. Do you agree? So how can you find this thing right here? We've talked about this in the past. We'll call it X. How can you find X? Use the Pythagorean theorem. Okay? Use the Pythagorean theorem. So how do you do that? You go x squared plus what? 12 squared equals 20 squared. And then you solve for x. Okay? All right, I'll give you the worksheet, and we'll go over more of that tomorrow.